Thank you very much. It's great to be here. This meeting about scientific forecasting, and scientists have a rather poor record as forecasters, especially astronomers. One of my predecessors as Astronomer Royal said in the 1950s that space travel was utter bilge, and that was a bad start. But undaunted, I'll be spending most of my time talking about our future in space. But a few other words before that. I have a reputation a bit as a pessimist because I wrote a book about 10 years ago which I called Our Final Century, ? And the publishers cut out the question mark, and when the Americans republished the book, they changed the title to Our Final Hour, with Americans like instant gratification and the reverse, I guess. And the theme of this book was that technology, although offering wonderful opportunities, has a downside because it empowers individuals and small groups. And in our more interconnected world, then people can do a great deal of damage, either by error or by terror. And it'll be very hard to control this. And there are two areas where one does have concern. One is in robotics and cyber. My friend Jan Chalin talked a bit about his worry, which is that perhaps intelligent machines will have a mind of their own, which may not have goals the same as ours. So there's a downside from the advance of computers and robotics, even though there's tremendous potential from them. And another important area is synthetic biology. And in fact, I was just yesterday afternoon across the Atlantic, which is why I'm rather jet-lagged now. I came overnight back from Princeton, where I was speaking at a wonderful event for the 90th birthday of Freeman Dyson, who many of you have heard of, who's a really visionary physicist, who's written about many aspects of the future. And he, in a recent article, speculated about an era where, just as he had a chemistry set when he was a kid, in the future, kids will have biology sets where they can create new species, like genetic engineering. Now, I think this is probably science fiction. If it wasn't, I think it would be curtains for us all pretty soon. So we wouldn't survive unscathed for long if everyone had the ability to engineer new genomes. Well, I don't want to say any more about these pessimistic scenarios, except to say that I do think we need to worry about the fact that we're in an interconnected world where even a few people can, by design or by error, have global consequences cascading through the interconnected system. But I want to talk about the question of whether humans, and even post-humans, have a future beyond the Earth. Well, I'm old enough to remember when Neil Armstrong made his first small step on the moon. But last man on the moon was in 1972, and many people here are too young to remember that. Certainly to my students, it's ancient history. They know the Americans landed men on the moon. They know the Egyptians built pyramids, but these both seem ancient history, motivated by strange national goals. But of course, in the ensuing 40 years, space has become crucial for practical purposes, sat-nav communications, environmental monitoring, etc., and unmanned space probes have beamed back pictures of varied and distinctive worlds, all the planets and their moons, etc., and you've all seen pictures of those. And it's interesting in a way that manned spaceflight languished after Apollo. Of course, people have been up into space, but mainly just into low Earth orbit, in the International Space Station. Had the momentum of the 1960s been maintained, the huge expenditure, there would be footprints on Mars by now. But of course, after Apollo, the political impetus for manned spaceflight was lost because the aim was just to beat the Russians and there was no prestige reason to go on further. And that was one of many instances where there's a gap between what could be done with the resources and what actually happens. Another example is a Concorde supersonic plane, which has now gone the way of the dinosaurs simply because there's no demand for it. And there's a big gap and a growing gap between what we can do with resources and what we decide is worthwhile or sensible actually to do. And the question I've got to ask is, will it be sensible for manned spaceflight to revive and go beyond the moon? Well, during this century, the entire solar system, planets, moons, and asteroids will be explored and mapped by flotillas of robotic craft. And I think there will then be big robots and fabricators in space, space mining of asteroids. I'm not sure that makes much sense if you want to bring the stuff down to Earth, but if you want to build huge structures in space, it makes sense to get the materials from there. So I imagine that the Hubble telescope successors, with huge gossamer-thin mirrors up in space, will be assembled under zero gravity using materials that are made in space. But what role are humans going to play in the future? And I'm going to look forward first 50 years, then hundreds of years, and then even beyond that. The practical case for sending people into space is getting weaker with each advance in robotics and miniaturization. And speaking as a scientist and practical man, I see no case for sending people into space at all. But speaking as a human being, I'm an enthusiast for manned missions. And I hope some people now living will walk on Mars as an adventure and as a step towards the stars. But it could be the Chinese will have an Apollo-type program, and if they have that, then they would certainly go for Mars, because for the Chinese to go back to the moon would not be a sensible way to assert their parity as a superpower with the US, because they'd be doing what the Americans did 50 years earlier. So if the Chinese want a prestige program, they've got to go to Mars. But unless that happens, then I think the only future manned exploration beyond low Earth orbit will be cut-price ventures, maybe privately financed, accepting high risks, accepting perhaps even one-way tickets. And these missions will be privately funded, because no Western governmental agency would expose civilians to such hazards. Indeed, the problem with the NASA program was it was so risk-averse. The shuttle failed twice in nearly 140 launches, less than 2% failure rate. And of course, for test pilots or adventurers, that's an acceptable rate. But each of those failures was a national trauma, because the project had been presented as being routine and safe. That was a big mistake. But I think there will, even for high-risk ventures, be lots of volunteers driven by the same motives as early explorers, mountaineers, and the like. As you know, private companies, like the SpaceX company run by Elon Musk, are already going to offer orbital flights pretty soon. And indeed, there's a prospect of a trip round the backside of the moon, not landing, but going further than any human beings ever gone before, and coming back. That takes 5 days. The fare will be $150 million. I'm told they've sold a ticket for the second flight, but not the first flight. And that may tell you something. And there's a similar idea promoted by Dennis Tito, an entrepreneur and former astronaut. He wants to send people to Mars and back without landing, going around the backside of Mars. That would take 500 days in isolated confinement in a capsule. So he says the ideal crew would be a stable couple, old enough that radiation damage doesn't worry them. Yeah. And there is indeed also a scheme being talked about that will allow you to land on Mars, but there you will stay, no return ticket. And there are volunteers for that. Just as there were volunteers centuries ago to go into the unknown and often not come back, exploring remote continents on Earth. And I think the word space tourism should be avoided. It lulls people into thinking that such ventures are routine and low risk. And if that's the perception, then the inevitable accidents will be traumatic, like they were for the space shuttle. So these cut-price ventures must be sold as dangerous sports or intrepid exploration. But don't ever expect mass emigration. It's absurd, as some people say, to claim that we can solve the Earth's problems by escaping or sending huge fraction of our population away, because there's nowhere else in space that we know of in our solar system as clement as the Antarctic or the top of Everest. Nonetheless, a century or two from now, there may be small groups of pioneers living independently from the Earth, maybe on Mars, maybe on an asteroid or comet. And whatever ethical constraints we impose here on the ground, we should surely wish these adventurers good luck in genetically modifying their progeny to adapt to this alien environment. And we have huge genetic knowledge by then. This might be the first step towards divergence into a new species, the beginning of the post-human era. Future evolution, remember, will happen not by Darwinian selection, but on the technological timescale allowed by genetics. Well, that's a scenario looking a century ahead. Incidentally, one of the problems with spaceflight is the problems of chemical fuel. The reason that interplanetary travel and all space travel is so difficult is that the weight of fuel has to be larger than the rate of the payload. And if you had some more efficient fuel, like nuclear fuel, it would not only allow much higher in-course speeds, which would cut the transit time to Mars or the asteroids, but it could transform manned spaceflight from high precision to an almost unskilled operation. After all, driving a car would be a difficult enterprise if, as you have to do for space voyages, you had to program the entire journey in advance and couldn't make mid-course corrections. But if you have plenty of fuel, then if you're in space, then you can make mid-course corrections, brake and accelerate at will, and interplanetary travel would then be a doddle. Indeed, simpler than driving a car or a ship, because the destination is always clearly in view. So it's only the shortage of fuel which makes space travel a high-precision operation. But let me now look further ahead, not to the planets, but to the other stars. And remember that to get to the stars by a chemical rocket would take tens of thousands of years. Interstellar travel is therefore, in my view, going to be a post-human enterprise. And what a post-human is going to be like? Will they be organic or silicon-based? We don't know. They could be organic creatures that have won the battle with death, or perfected the techniques of hibernation or suspended animation. We don't know what they will be. But if we were to look 1,000 years ahead, and obviously this is a crazy extrapolation, then travel to other stars could be technically feasible. But even if it became feasible, and if there were rockets that could allow you to get there, would there be a motive? Would even the most intrepid want to leave the solar system? Well, of course, we can't predict what inscrutable goals might drive post-humans, but the motive would surely be weaker if it turned out that there was nothing very interesting out there, if there weren't other biospheres. After all, European explorers in earlier centuries who went across the Pacific were going into the unknown to a far greater extent than any future explorers would be, and facing more terrifying dangers. But of course, they fully expected there'd be wonderful fauna and flora on the new continents they would find. And I think there'll be a compelling motive only if previous unmanned probes have shown that there are planets which have some sort of biosphere. Well, what's the chance of that? Well, as you probably know, people are looking for evidence of life in our solar system. On Mars, under the ice on Europa, Jupiter's moon, and one or two other places. There may be something, but no one expects very much. But if we look further afield, things are very different. And one of the most exciting developments in astronomy in the last 15 years has been the realization that most of the stars you see in the sky aren't just sort of twinkling points of light, but they are objects like the sun, and moreover, they are surrounded, many of them, by retinues of planets, just as the sun is surrounded by the Earth and the other familiar planets. And observations made in particular with the Kepler spacecraft have found evidence for very many planets, some rather like the Earth. And obviously, if we're looking for life, the first place to look would be a planet rather like the Earth, the size of the Earth, and orbiting at a distance from its parent star such that water can exist, neither freezing all the time nor boiling away. And there are many planets surely like that. But even if we find Earth-like planets, do we expect alien life on them? We don't know the answer to that question. That's because we know very little about how life began on Earth. We understand how life evolved, but what made the transition from non-living to living, to the first metabolizing and reproducing object, is still a mystery. It might have involved a fluke so rare that it happened only once in the entire galaxy. On the other hand, the transition might have been almost inevitable given the right environment. We just don't know, nor do we know if the DNA, RNA chemistry of terrestrial life is the only possibility, or just one chemical basis among many. So we don't know how complicated or how common simple life is. But even if simple life were common, it's of course a separate question whether it's likely to evolve into anything we might recognize as intelligent or complex, whether Darwin's writ runs in the entire cosmos, as it were. Perhaps the cosmos teems with life. On the other hand, our Earth could be unique among the billions of planets which exist, in which case we need be less cosmically modest, tiny though the Earth is. And it might be too anthropocentric, as it were, to limit attention to Earth-like planets, because science fiction writers have ideas of life of other kinds, for instance, balloon-like creatures floating in the dense atmospheres of Jupiter-like planets, swarms of intelligent insects, nanoscale robots, etc. They could be diffuse living structures freely floating in interstellar clouds. They'd live very slowly, but nonetheless they could come in their own in the long-range future. So we certainly don't know what's out there. Well, of course, there are people who think they do know. In fact, I get letters from people who think they've been visited by UFOs or abducted by UFOs, etc. And I respond to these people by saying two things. First, do you really think that if the aliens had made the colossal effort to traverse interstellar space to come here, would they just make a few corn circles, meet a few well-known cranks, and go away again? Doesn't seem likely to me. And the second thing I tell these people is to write to each other and not to me. Well, maybe we'll one day find ET. On the other hand, the searches may fail because Earth's biosphere may be unique. But even if life is unique to the Earth, that doesn't mean that life is a cosmic sideshow. Because the other point I want to emphasize is that evolution is just beginning. We are the outcome of 4 billion years of evolution on the Earth, but our Earth has 6 billion years more to go before the sun flares up and dies. And the universe has a potentially infinite future. And to quote Woody Allen, eternity is very long, especially towards the end, and a lot can happen before then. And in particular, life from Earth could spread through the entire galaxy, evolving into a teeming complexity far beyond what we can even conceive. And if so, our tiny planet, this pale blue dot floating in space, to use Carl Sagan's nice phrase, could be the most important place in the galaxy. And the first interstellar voyages from Earth would have a mission that would resonate through the entire galaxy, because they'd be greening the entire galaxy, as it were. So it's important to realize that post-human evolution, here on Earth and perhaps far beyond, could be as prolonged, at least, as the evolution has led to us, and even more wonderful. And this conclusion is strengthened when we realize that future evolution will proceed not on the million-year time scale when Darwinian selection makes a species form, evolve, and become extinct, but at the much accelerated rate allowed by genetic modification and the advance of machine intelligence, and forced by the drastic environmental pressures that will confront any humans who will construct habitats beyond the Earth. As I said already, the post-human era could start within a few hundred years. Darwin himself realized this. He wrote in his book that no living species will preserve its unaltered likeness into a distant futurity. But we now know futurity extends far further than Darwin envisioned, and we know that the cosmos to which life could spread offers a far more extensive and varied habitat than he ever imagined. So humans are surely not the terminal part of the evolutionary tree, but a species that emerged perhaps early on in the overall roll call of species. But nonetheless, maybe a species with special promise for diverse evolution and perhaps of cosmic significance for jump-starting the transition to silicon-based and potentially immortal entities, and they're the ones that can transcend human limitations and perhaps do interstellar travel. Well, in cosmological terms, or indeed in a Darwinian time frame, a millennium is but an instant. But that's far further than we could predict in terms of technological evolution. But let's fast forward not for a few centuries, not just for a few millennia, but for an astronomical timescale, millions of times longer still. The ecology of stellar births and deaths in our galaxy will proceed gradually more slowly as the gas gets used up. There'll be a big jolt in 4 billion years, incidentally, when the Andromeda galaxy crashes into ours. But the debris of our galaxy in Andromeda will survive for much longer. Time enough, perhaps, for a galactic-scale intelligence to emerge as the culmination of the long-term trend for living systems to gain complexity and negative entropy. Freeman Dyson and others have imagined that all the atoms that were once in stars and gas could be transformed into structures as intricate as a living organism or a silicon chip, but on a cosmic scale. Well, this is a scenario for the very, very far future, far post-human. A word now about physics. All of what I've said is assuming that we are constrained just by the physical laws, the law of gravity, and the laws of physics and chemistry. And it's true, so far we can tell, that those laws prevail everywhere we can see in the universe. Atoms in the most distant galaxies seem from spectral evidence just like the ones we study in the lab. But there's been another expansion of our horizons in cosmology. We've realized that what we've traditionally called the universe, the panorama of billions of galaxies we can see, even with a big telescope, may be just a tiny fraction of physical reality. There may be many, many more galaxies beyond our horizon whose light hasn't had time to reach us and maybe never will. And moreover, that's just the aftermath of our Big Bang. And it's thought by some people that we live in a multiverse of many Big Bangs, not just one. And each constituent of this multiverse cooled down differently, perhaps ending up governed by different laws. So just as the Earth is a very special planet among zillions of others, so on a far grander scale, our Big Bang may have been a rather special one, because it may be one of the few Big Bangs in which the governing laws allowed complexity to evolve. Many of the other Big Bangs may lead to sterile universes because they don't allow chemistry, gravity isn't strong enough, or something like that. So in this huge perspective, what we think of as universal laws wouldn't be universal, they'd just be parochial bylaws in our cosmic patch of the multiverse. So our current concept of physical reality, even if we're astronomers, could be as constricted in relation to the whole as the perspective of the Earth available to a plankton in a spoonful of water that doesn't know all about the rest of the Earth. But that's not all. There's a final disconcerting twist I wanted to mention. Post-human intelligence, whether in organic form or in autonomously evolving artifacts, will develop hypercomputers with the processing power to simulate living things, even entire worlds. Perhaps advanced beings could use hypercomputers to surpass the best special effects in movies or computer games so vastly that they could simulate a universe fully as complex as the one we perceive ourselves to be in. Maybe these kinds of superintelligences already exist elsewhere in the multiverse, in universes that are older than ours or better tuned to the emergence of superintelligence. Well, what would these superintelligences do with their computers? They could create virtual universes vastly outnumbering the real ones. So perhaps we are artificial life in a virtual universe. And that concept opens up the possibility of a new kind of virtual time travel, because the advanced beings creating the simulation can, in effect, rerun the past. It's not a time loop in the traditional sense. It's a reconstruction of the past, allowing the advanced beings to explore their history. Well, I hope I've said enough to indicate that possibilities once in the realms of science fiction have shifted into serious scientific debate. From the very first moments of the Big Bang to the mind-blowing possibilities for alien life, parallel universes and beyond, scientists are led to worlds even weirder than most fiction writers have envisaged. But nonetheless, my final word is this, that the pale blue dot we live on in the cosmos is a special place, and even in a concertina time span where it's existed for billions of years in the past and will for the future, this century is a special time, because it's the first time when one species, namely ours, has the power to control the future of the planet. Thank you very much.